Hello, and thanks for joining us today for this latest Data Science Central podcast. This is Bill Vorhies, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. Now, today's podcast is sponsored by Nvidia, and we very much appreciate Nvidia's support of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, this podcast will be about 15 minutes long. We have one speaker who I'll introduce in just a minute, and today's talk is entitled, Selecting an Enterprise Deep Learning System. Our speaker today is Tony Paikeday, who is Director of Product Marketing for Nvidia Deep Learning Systems. Now, with over 25 years of experience in product management and marketing, business process, and manufacturing engineering, Tony helps organizations infuse the power of deep learning to solve their most important business transformation opportunities. Tony holds an engineering degree from the University of Toronto. So Tony, hey, thanks for being with us today. Now, I understand you're going to talk about how every organization wants to infuse the power of AI in its business. So in this first of two parts, we'll explore the journey from development to production deep learning, learn how to enable an end-to-end workflow that's optimized for the rigors of deep learning in an enterprise setting, with predictable performance as your neural network models and data sets grow. So Tony, let me ask you a question. What's NVIDIA's role in helping organizations tap into the power of AI?
Great question, Bill, and thank you for that. We began this journey over a decade ago, beginning with the focus we put into exposing the computational power inside the modern GPU such that developers could effortlessly tap into its massively parallel architecture to solve important problems. Over the years, we've continued to invest in that architectural innovation that's delivered massive performance gains, where by comparison, CPU architects have seen continued deceleration as they struggle to expose instruction-level parallelism at an increasing power and footprint cost. Now, that deceleration is in stark contrast to where GPUs are taking us. In the last 5 years, we've witnessed a 500 times gain in performance, which has made it well-suited to AI. And this is evident back in 2012, in fact, when AlexNet outperformed and won the ImageNet competition by a significant margin, powered by GPUs. So this was a milestone event that set the course for what's to come. Now, with the advent of deep learning and its insatiable demand for parallelized computation, GPU computing has become the unique enabler for delivering scalable AI performance that can be harnessed by really every enterprise.
Well, Tony, thanks for that insight. Now, are enterprises really making a success of AI and deep learning?
I love this question. I was asked recently if this AI gold rush is really more about selling picks and shovels and less about actually finding AI gold. I have nothing against picks and shovels, but what really excites me is what I hear from customers every day, namely how they're transforming their business ops, their products, their services, using our technology and AI in ways that we never imagined. Think of large industrial sites, for example, with decades-old infrastructure and companies that need to inspect those facilities for corroding pipes or crumbling smokestacks. We're talking about some pretty inhospitable places to send a human being. Companies can spend over $100 million a year inspecting these places and up to 5 times that in maintenance. Innovative companies like Baker Hughes GE and Avitas Systems are using our DGX AI systems to enable drones and robotic inspection technologies powered by deep learning, reducing inspection and maintenance costs thanks to AI-powered risk evaluation for their customers, and accelerating inspection intervals. That's real money to an oil and gas company's bottom line. Another example I like to use is DeepGram and what they're doing for enterprise call centers. Most enterprises only listen to about 2% of their recorded calls. That's valuable info that can help train agents understand and predict customer churn, improve customer satisfaction. But the transcription process is maybe 20% accurate, and it takes a long time. DeepGram's using deep learning with our DGX platforms to help enterprises mine 100% of their recordings with incredible accuracy. SAP is another great example. I think 80% of the world's transaction revenue touches their systems, and they're working with us to AI infuse almost every aspect of modern enterprise. SAP Brand Impact is solving the age-old problem of how to quantifiably measure ROI of brand marketing investments For example, when you sponsor a sporting event and place your logo on the sidelines, they're using machine learning to enable automated detection of brand placements in video feeds to calculate the impact in terms of audience impressions. So if you're a CMO weighing the value of those investments on your business, you now have a way to make that correlation. And SAP is a great example of someone who's doing it using our platforms.
Well, Tony, thanks for that answer. Now, when would you need to think about an on-premises approach versus the cloud, for example?
You know, every customer is on a journey, one that starts with what I call initial exploration and discovery, playing with deep learning frameworks, grooming data sets, experimenting and tuning. And it's one that someday grows into a production-scaled environment that's doing something mission-critical to an organization's success. Now, cloud has a remarkable enabling effect on those early experimenters taking the first bite into deep learning without getting bitten by the lack of budget or delay to getting started, using the simplicity, efficiency, and elasticity of cloud to meet their needs. As these experimenters start working into bigger, sizable data sets and as they start building their business case, as they aspire to a production operation that necessitates enterprise caliber uptime, basically, as they move from crawling to running, they start to weigh various factors, including the cost to move data from where it's landing to where the compute for training resides. Now, they start to think about the cost per training run and its impact on iteration speed and developer creativity. So to illustrate this, let me share an example from one customer, CloudSite. They started in the cloud building their image cognition platform. Their image database grew from a couple million to multi-millions of images. They started running more and more experiments to optimize their platform, and they started to see that the rising cost of more and more training runs was instilling fear of failure in their data scientists. It got to the point that they would spend inordinate amount of time making sure that everything was just perfect before a run, hurting their agility and advancing platform development. So they moved to an on-premises workstation, in fact, the predecessor of our DGX station, and started to immediately notice that they were saving money on data I/O and storage costs and reducing the cost per training run. And when their data set grew to over 500 million images, they seamlessly ported their work to a DGX-1 server in their data center to get the scale-up performance they needed. So this has helped them ensure that they could hit the lowest possible cost per training run. As a result, their data scientists could experiment freely, they're more creative, they're not afraid of failure, and trying different permutations in their model and responding to customers faster. So ultimately, they're delivering a better service to their customers. Now, I'm not going to say that every organization will follow this trajectory, but it bears consideration. If you're dealing with increasingly large models, data sets, and you need the freedom to fail fast and derive insights even faster, this is a great way to go, especially if you're aspiring to deliver an enterprise-grade service and you need autonomy over your platform, sovereignty over your data, and the reassurance that if something breaks, there's expertise waiting to help you.
Well, Tony, thanks. That was a very important distinction between those points. Now, why did Nvidia build a family of AI solutions when there are already a lot of systems out there using your GPUs?
Great question. I think the answer lies within the fact that for an enterprise, it's no small feat to turn up a deep learning platform that's ready for production training. Assuming your organization knew exactly what to do and had all the constituent pieces of software and documentation at your fingertips, you'd still be in for a long-haul effort of building a hardware platform tuned for the rigors of deep learning, carefully selecting components, including the right mix of storage, RAM, CPU, and I/O, including GPU communications topology, then integrating these, troubleshooting conflicts. Now, let's look at the software. Assuming you've chosen a deep learning framework, or a couple, engineering a stack inclusive of the framework, the libraries, the communication primitives, and drivers, that software engineering effort is multiplied by the number of frameworks you might want to experiment with in parallel as you seek the best possible training times and accuracy, and it's compounded by the fact that the open source versions are not optimized for maximum GPU accelerated performance, which is why you're doing this in the first place. So now consider that the frameworks themselves are constantly being updated and new innovations land in these open source versions constantly, each of which could necessitate a respin of your stack or stacks, and more engineering effort is then required to optimize and QA. And we haven't even gotten to the OS image running on the hardware. In database and web and other traditional workloads, you can rely on robust, long-lived Linux branches and can safely stay away from bleeding-edge kernel features. The opposite is the reality for AI, where innovation means you have to take advantage of the latest OS features, but that means you need a rigorous discipline of QA testing that keeps pace with the rate of churn in the OS. This is where you need the ability to balance enterprise stability with the call of the bleeding edge. The question for customers becomes, who's providing your OS image? Do they understand its relationship with the layers above? Now let's shift view for a moment. Like, what if you're the IT person supporting a team of data scientists? You select and deploy a GPU server, they deploy a stack, everything's running fine, but a couple of weeks later, after a stack update, they notice their PyTorch model is running 30% slower for some reason. They call you to put in a ticket. You're looking at this thing and wondering where in the stack, across this confluence of open source software, libraries, drivers, and server hardware is my problem. Your enterprise is paying a lot of OpEx to hire and retain data science professionals, but the clock is ticking while you're literally looking for a needle in a haystack across multiple vendors and community forums. So it's hard to run a business that way. So yes, there are definitely alternatives in how one can implement GPU computing in the enterprise. But the various scenarios I just described are the reasons why we, as NVIDIA, decided to create purpose-built enterprise-grade solutions for AI and deep learning, the DGX portfolio of AI supercomputing systems. We've taken everything we know about this space, designed industry-leading hardware and software, wrapped it with 24/7 support and AI expertise to do three key things really well. For organizations that want to first have a fast start with systemized products that offer a plug-in and power-up deployment experience so you can start experimenting in hours. Turn on the appliance, download your pre-optimized versions of your favorite frameworks. We've done them all, TensorFlow, MXNet, PyTorch, Caffe2, all of them, pre-integrated with our software, packaged in containers. Then, you have to consider that these are all engineered by our team for maximum performance, which represents hundreds of thousands of dollars in software engineering OpEx that you no longer carry on your books. Second, we keep you productive. As the frameworks evolve, and they constantly do, we implement the best optimizations. We publish them to our NVIDIA GPU cloud. We've already done the QA testing. Just download and start training. And I guess third, we wanted DGX to be the standard bearer of the latest innovations in revolutionary AI performance. The first place you could turn for leading-edge AI technology before it's available anywhere else, but packed with a peace of mind knowing that we stand behind it. So around this, we created three great offerings. DGX Station for developers at the desk side who wanted the power of a data center at their fingertips, DGX Server in the data center for production-scale deep learning training, and DGX2, the world's first 2 petaflops compute node for unprecedented levels of model and data parallelism. All these built on the same stack, supported by the NVIDIA GPU cloud, optimized to ensure predictable high-performance execution on all of them.
Well, Tony, thank you for that insight. Now, how should we think about deep learning workflow and how that impacts platform selection?
End-to-end workflow is so important when you think about platform selection and how you'll enable faster iteration without impacting developer productivity. Let's think about the problems that I just mentioned. When you think about DGX Station, consider that most data scientists don't want to be dependent on access to a shared resource in the data center, but they need a versatile, easily accessible platform that supports their need to experiment, tune, run more experiments, all the while refining their neural network until it's ready for production training. They really want a fast procurement cycle, a rewardingly simple unboxing experience, and an installation that's quick so they can get started experimenting. Once they're ready, they want to embark on productive experimentation, tuning and optimizing their models, collaborating with coworkers, and deriving insights from their data. They can do all this on their DGX Station, knowing that their work is easily portable between their workstation as well as a DGX-1 that may be sitting in their data center. This portability is enabled with no recompilation of code necessary. You just push the container back to the NVIDIA GPU cloud and then deploy it from there to a DGX-1 or even another station for your production training when you're ready. Then when you're ready for training at large scale, that same work can extend to a cluster of compute nodes, DGX-1s or even a DGX-2, as I mentioned earlier. Additionally, their trained models can be leveraged for deep learning inference, optimized, and thanks to the versatility and power of Volta-powered DGX systems and other dedicated inference platforms using TensorRT, we can now help organizations derive insights from the field that can be then fed back to the experimentation phase where we all started for instance, further model improvements. So we really believe that taking this end-to-end view is critical if you're an enterprise building a business-critical application that needs to scale and needs to deliver continually improving performance over time.
Well, Tony, thanks. That was a very interesting discussion. And I'd like to thank NVIDIA today, again, for sponsoring our event, our podcast, and particularly our speaker today, Tony Paikeday, for his insight into today's topic. This is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on DSC's next podcast. Have a great day.